Today in Capechi's Corner, we're going to look at factoring quadratic trinomials. Now, there are a lot of different methods that you can factor trinomials with quadratic form, but what we're going to do today is we're going to use the X method. So the X method, we're going to take the number that we need to multiply. We're going to put that on the top of the X. And the number we need to add, and we're going to put that in the bottom of the X. And then we're going to try to work on combinations of the two numbers that work for both the product and the sum. Now, a couple of things when we're factoring. If the last sign of our trinomial is a plus, then the signs are the same. They're either both plus or they're both minus. If the last sign of the trinomial is a negative, then our signs are going to be opposite, either plus minus or minus plus. The order doesn't matter. All right, so let's take a look at number 1. So the last number, that's going to be the number we're trying to find products of. So we're going to try to find numbers that when I multiply that, what factors of 27 when we multiply, and this 12 is where our sum is going to be. What numbers that are basically multiplying to get to 27 and are adding to get to 12. So in this case, it's going to be 9 and 3. Right? 9 times 3 gives us 27, and 9 plus 3 gives us 12. So I'm going to set up my binomial. So I have y plus 9 and y plus 3. They're both positive. And again, the second sign's a plus, so the signs are going to be the same. They're going to take on the sign of the first one, plus and plus. Now we can check it. We're not going to check everyone, but we can check it by using FOIL. So y times y is y squared. My outside gives me plus 3y. My inside gives me plus 9y. And my last is 27. When I combine my middle terms, I get y squared plus 12y plus 27, which is what I wanted to start with. So I'm all set. All right, let's take a look at the next problem. Again, factors of 6, that when I add, I get negative 5. So 3 times 2, they multiply to get to 6. And if I make them both negative, when I add them, I will get to negative 5. Negative 2 times negative 3 gives me positive 6. Now again, the second sign's a plus. They're going to take on the sign of the first one. They're both going to be negative, which we can see here. So I'm going to have b minus 2, and I'm going to have b minus 3. And then I'm all set. Okay, we're going to keep going. In number 3, we're looking at factors of negative 40 that when I add, I get 3. So when it's negative 40, I know that I'm going to have one positive and one negative. So 8 times 5 does give me 40. Now my 8 is my higher number, and my sum is going to be a 3, which is positive. So I know my 8 has to be a positive 5. My 8 has to be positive and my 5 has to be negative. So again, 8 times negative 5 gives me negative 40, and 8 plus negative 5 gives me 3. So I know I'm all set. So this gives me j plus 8, and I get j minus 5. Okay, moving on to our next one. Again, my last sign's a negative, so I know I'm going to have one of each, a positive and a negative. So again, factors of 45 that when I add, I get negative 4. I'm going to go 9 times 5. One of them needs to be a negative in order to get me negative 45. This negative is going to go to my higher factor, so negative 9 times 5 gives me negative 45, and negative 9 plus 5 gives me negative 4, so I'm all set. So my negative is going to go with my 9, and my positive is going to go with my 5. All right, let's take a look at the next one, number 5. In this case, I can set it up. My signs are the same. They're both going to be negative. Factors of 8, so I have 8 and 1, and I have 4 and 2. Now my signs are the same, so I know I'm going to try to add something, whether positive or negative, that's going to get me to negative 4. But in this case, 8 plus 1 gives me 9, and 4 plus 2 gives me 6. I don't have any other factors of 8, so this one we can't do anything with. So we just say that it's not factorable. We tried, but there's no combination that's going to work for that quadratic. Okay, up to this point, we have not had to take our add a greatest common factor. if you look at some of the previous problems we did, there was not a greatest common factor, but that's going to change in number 6. I realize with number 6 that I can factor out a 4. That 4 goes into each term. So I have 4, and I have p squared plus p minus 6. Now, I originally set up my numbers, but I realize now that I'm not going to do that because I factored out a greatest common factor. So I have to go back and I have to adjust. So this negative 6, again, that's going to go on the top. And under here, that p is really 1p. So that's what's going to go underneath that x. So now I'm looking for combinations of 6, factors of negative 6, that when I add, I get 1. So I have 6 and 1, or I have 3 and 2. So 3 and 2 is going to work. I need it to be a positive when I add. So this 3 is going to be positive, and my 2 is going to be negative. 3 times negative 2 gives me negative 6. 3 plus negative 2 gives me 1. So I'm going to end up with 4 times p plus 3 and p minus 2. So now we're actually going to check this one just so we can see how the check process is going to be a little bit different. So we're basically going to work backwards. So I'm going to bring that 4 down. Now I'm going to use FOIL. So I have p squared. The outside's negative 2p. Then I have plus 3p. And then I have negative 6. So I have 4 times p squared plus p minus 6. Right? See, here is our answer. And we're basically working backwards. I'm going to distribute that 4 through. So I get 4p squared plus 4p minus 24, which is the problem I started with, so that I know I did that correctly. Okay, let's take a look at the next one, number 7. Now, in this case, I notice that my GCF, I don't have a number that goes in everything, but my lowest power is x to the second, so I can factor that out. So that gives me x to the second minus 15x plus 56. So I'm going to kind of bring that down here. So my 56 is going to go here. My negative 15 is going to go here. Now my last sign is a plus, so I know I'm going to have the signs are the same, and they're both going to be minus. So factors of 56, 8 and 7 are going to work because 8 times 7 gives me 56, and when I add them, I get 15. The only thing is I have to make them negative, right? Negative 8 times negative 7 gives me 56, but when I add them, I get that negative 15. So I have negative 8 and negative 7, and that x squared is part of my factored answer. All right, take a look at one more here. Again, this time I have a variable and I have a coefficient, a number that goes into both. So my greatest common factor is I have 5f to the 5th. It goes into all 3 terms, 5f to the 5th, 5f to the 5th. So that's going to come out, and I'm left with f to the second minus 2f minus 8. So again, this 8, that negative 8 is going to go there. That negative 2 is going to go here. My 5f to the 5th is going to come down. And I'm going to set up my parentheses. Factors of 8, that when I multiply, I get negative 8. One of them will be negative, and when I add, I get negative 2. So I know here I'm going to have negative 4 and positive 2. Again, it doesn't matter which spot you put these two numbers in. So that gives me f plus 2 and f minus 4. And that is my final answer right there. All right, let's look at our challenge question for today. When factor completely, which is the factor? So again, if I look at my answers here, I'm not asking just a factor. I'm asking which one is a factor. So it's just the wording is a little tricky. I'm going to factor it like I always did. I'm going to take out a greatest common factor, which looks like it's 6x. Factor at the 6x, and I'm left with x squared minus 2x minus 8. So my negative 8 goes up top. My negative 2 goes to the bottom. And look what happened. It's very similar at this point to what we had above. So I have negative 4 and positive 2. So my final factored form is 6x, x minus 4, and x plus 2. All right, but let's see what we said here. Which one is a factor? So I'm not listing all my factors. I'm just listing some. So when I take a look, it looks like x plus 2 is there, right? It's not x plus 4 because I have x minus 4, and these two aren't it. So the answer is letter A. Okay, thanks so much for stopping by today. You have a great day.